Hi everyone, my name is Sam and welcome to my Next Gen AI Guy YouTube channel. In this video, I will going to explain you how to build a one chatbot which can retrieve the data from a multiple database. I will explain you everything from the scratch. The whole code I will explain you in the VS Code. Before explaining the working flow of this project, let me give you the demo of this project, how exactly it works. So this is the chatbot which I have built with the help of Streamlit. First I will going to see what exactly it is replying. I will say hi, then it replied me, hello, it's nice to meet you, how can I assist you today? So I will say I want to buy apples. So as I have given the I want to buy apples, so accordingly first I have written the hi. So decision was taken from the LLM that just a normal message. Accordingly, it will going to run particular script and it has generated a response the hello back. So I have used the three data set. The first one is the grocery. The second one is the PDF which I have embedded and stored into the VectorDB, and third one is the image dataset of the clothes. So three dataset I have used, and based on the user query the LLM model will choose which database to use and accordingly it will going to retrieve the data. So here it has retrieved the data from the grocery store. Like I wanted to buy the apples, I just wanted to retrieve the whole data. So you can further utilize this data and show this image below over here. Front-end developer can make this UI more better. So I have asked the give me the blue suit cloth image. It has chosen the image dataset and it has retrieved data from that image database. So it has retrieved the blue suit images over here. So you can see that it is working fine. Now I will going to choose that third database, like how to fine tune LLM model. So in the third one, which is PDF VectorDB, what I did, I just loaded one PDF in which how to fine tune the LLM model. The whole things has been written, so that I have encoded with the help of embedding model and stored into this PDF VectorDB, which is ChromaDB. When I have asked the how to fine tune LLM model, so it has chosen the VectorDB, which store the information related to fine tuning, and it has successfully retrieved the dataset from this, and it has also retrieved the code from that PDF. So that was the demo of this project. So here I have utilized three database: grocery, image, and fine tuning. And other than that, it is able to classify that user query, is it normal or does it require the any data set. In case if it is required the data set, so in such scenarios it will choose that data set and it will retrieve the data from that given database. Before explaining the coding part, I will request you to please like and subscribe for more such videos. Also, it will give me a motivation to create such informative videos. So let's move to the coding part, how we can build such kind of application from scratch. Okay, so I have already told you that I am using three data. So all of this data is saved over here. Here I have saved the CSV data, and in this one I have saved the all images, which is around 1000, and the PDF data. In this one it is written how to fine tune LM model. Out of these three data, CSV data I am using as a raw. So in case of image and PDF, I am using embedding model, which will allows us to convert these data into vectors, which is numerical representation of text or images. So PDF data I have loaded and embedded and stored into this PDF VectorDB, and the image data set I have loaded and stored into this vector database after embedding with the help of OpenClip embedding model. I will going to explain you in the code also. So what I'm doing, whenever user write a query, that query will be converted into the Python code. That code I am executing by passing this data frame and retrieving the data and giving back to the UI. That's how I'm handling the CSV data. So here is the .env file. .env file is used to store the credential. I am using a grok to access the free LLM model from there through API key. So that API key I am storing over here. And this one is the app.py file, which is the main file where I have written the whole code and integrated with the Streamlit UI to run the application. And this one is the embed pdf.py file. How to do that I will going to explain you, but let me just give you the overview of those all files which is over here. So this one will going to load the PDF and split into the chunks. Then we will going to use embedding model, which will allows us to convert that chunks of that PDF into a vector format, which is numerical representation of text. After that we will going to store into this vector database you can see over here. And this one is the to load the dataset from the Hugging Face. I have utilized the image dataset from the Hugging Face. This module will going to load that dataset from there. This is one is the prompt. This is the prompt template which I have written over here, and here is a requirement.txt file. All the packages are written over here to run this project. And the last one is the store embed image. This one is to load that images from this folder and convert into a vectors, then it will going to store in this vector database. So let me first explain you the how I am handling the image dataset. So this one is the beginning load data. So I am importing the load dataset from this dataset, which will allows us to load the all the data from the Hugging Face. Over here I have given the path. I can show you that one also. First go to the huggingface.com, and over here just paste this one. So this is the dataset which I am using. This path I have given in our code, so that will allows us to load the data from the Hugging Face library. Okay, after that I am importing OS operating system. Next, this is the data folder where I want to save that images. So this here all the images will be saved after the loading. After this I am importing the os.makeDirs, which allows us to create a directory. So it will check that if this directory exists, then it's okay, otherwise it will going to create that directory. Here I have written the one function which allows us to save the images. As an input it will take the dataset, means this loaded dataset, the dataset folder where you wanted to save, and number of images you wanted to save. I wanted to save only 1000, so that many images I will going to load. One by one I am looping through it, the number of images over here. What I am doing over here, I am taking the one by one images from the training section. So I can show you. So over here you can see that in the training it has 45.6k rows, means that number of images it is having, and one by one I'm going to load that image and save that image to this directory. So I have written to save this image.save os.path.join, means it will going to join this folder name and image_i+1. So that is the name of that image. The image_1.png, that's the image name which I have written over here. One by one it will going to save till the 1000. So I am calling that function over here by providing the data set which is over here, then dataset folder and number of images 1000, and finally I'm printing that save the first 1000 images to this dataset folder. So after saving that images, what I'm doing is storing that images into the vector database. For the vector database I'm using a ChromaDB. Earlier the ChromaDB was just used to store the text data into a vectors format. Now it supports the images also, so you can load the images, embed it and store into the Chroma database. For the embedding function I'm using OpenClip embedding function module from this chroma.utils.embedding function. So recently you must have heard about it, that with the help of OpenClip embedding model we can embed those images and store into the VectorDB. For that one I'm using OpenClip embedding model. And next, importing the image loader from the chromadb.utils.dataloader. It will going to load that images from this folder. So this is the image data folder. I will going to pass the path over there. So that data folder I have given over here, and persist client functions allows us to store VectorDB locally. So I am storing over here. So that path I have passed over here. And next, image loader function, which will going to load the images, and OpenClip embedding model function to do embedding on that images. So here I have created a chroma client dot get or create collection. So that collection I am creating, and the name of that collection is image. Embedding, I have to pass the embedding function which is over here clip, and the data load function which is image loader. So image loader which is over here, that I am passing here. Next is the ID and URIs, unique resource identifier. So each image will going to have its IDs and URI. First I am going to looping through one by one in the dataset folder. I am loading the only images which extension is .png. So that file path is going to be URIs, means unique resource identifier, and IDs is going to be I, means one by one index number. So that is the ID and this one is the URIs. So those two information which will be added to that image vector DB. So here I am adding adding to the image vector database. And finally, I'm printing the image stored to the vector database. Next, let me explain you about the PDF one. So how I'm handling the PDF. You must aware of that we have so many frameworks. Two are the most popular one, LangChain and Llama Index. So both are the framework which allows us to build a LLM based application. In this project, I am utilizing the LangChain. You can watch my other videos where I have utilized the Llama Index also. This is the module which allows us to load that PDF data, which is over here, fine-tuning.pdf. So that PDF we will going to load, then we will going to convert with the help of embedding model. After that, we will save into this PDF VectorDB, which is ChromaDB. So first I am importing the recursive character text splitter from the LangChain.text splitter. We have several kind of text splitter like character base or others are also there. I am using recursive character text splitter, which will going to split that whole text recursively till the end. And after that, I am importing sentence transformer embedding. You can use other embedding models also. For demo purpose, I am using sentence transformer embedding model from langchain_community.embedding.sentence transformer. The embedding model exactly I am using is All-Mini LM-L6 V2. So this embedding model which I am using to convert that text into a vectors, which is numerical representation of text. After that, I'm importing the chroma from the LangChain community.vectorstore. There are also Facebook AI similarity search based, so that one you can also utilize if you want. After that, I'm importing the path from pathlib. Next, I am importing the document from langchain.schema and pipedf2. So here I have given the directory path where my data is stored. Next, I have written the function load pdf_text pipedf2. Here I have passed the file path, which will going to be this one. Next is a empty string, the text. Then I'm opening that file path where that data is stored. RB means read binary as a file. So I'm using read binary to read this file with the help of pipedf.pdf reader, and it will going to extract the text. Each pages will be loaded and it will going to read and extract the text into this variable. So here I have called this function which is written over here, and I'm appending that whole document in this list. This list will contain the exact format which is required to do embedding and store into the VectorDB for efficient retrieval. In the page content section, loader text I will going to save over here, and the metadata I will pass path of that file. So that metadata information I am passing in this source key. Now I will going to split that whole loaded text which is stored in this documents variable recursively. So chunk size I have given 200 and chunk overlap is given over here 20. Means if you have imagine you have a 3-page of document, each page will be split into a 200 chunk size and the chunk overlap is going to be 20. So first chunk will be 200 and the next chunk will going to have the 200 words. So first chunk last 20 word will be same as the next chunk first 20 words. So it sounds complex, but it's quite easy. Next we are going to initiate this text splitter, and from that we are using the split document function. It will going to split that document recursively. After that we are loading the embedding model, which is All-Mini LM-L6 V2. So that embedding model which I am loading over here, and this is persist directory where I wanted to store the whole loaded and embedded vectors into the PDF VectorDB. And here I have passed the whole, the chroma.from documents, I have passed the docs which is splitted, and embedding function which is over here, and the persist directory where I wanted to store the embedded document. So with the help of this module we are doing those all things. Next let's move to the final part, which is app.py. So first we are importing the streamlit for a UIs, pandas to handle the data frame, _grok.chat model. We are importing the chat grok. So let me show you the grok. You must be aware of that, but let me give you the introduction again. So this is the Grok, which is quite a good platform where you can utilize the free LLM model from the API key. Here you need to click on this free API key. If you wanted to create an API key, then you can click on by passing the API key name, and it will going to create a API key. That secret key you can copy and paste into the .env file. Here is the playground also, and the documentation. It provides several kind of models. All the models name you can find it out over here. It's really great platform. I can say it has the recently launched Llama 3.2 models. All the variants we have, like a vision also. So if you wanted to use the other models, you can choose the model based on your needs. I have Llama 3.1 70 billion versatile model. So that's the Croc model which I am use. If you wanted to use OpenAI models, Gemini model, that also you can do. And after that, I am using the prompt template. So prompt template will allows us to give the instruction to the LLM model what exactly it has to do and how the output should be. So that template you can define. And here I have imported the retrieve QA chain, so I can build a chain of a retrieval for the PDF. That chain will allows us to add the multiple components and build one particular chain where you will give the query and it will use all the components and retrieve the output accordingly. Here I have given the sentence transformer embedding, which I have already told you, and the load.env file from the .env, which will allows us to load the credential from the .env file. And from the prompt, I am importing the prompt template for a question. This is I have written over here to handle the CSV data. So in this one, I have given just information about my data set. So what are the columns I am having, and here I have given you are an experienced data analyst. I have defined its job, so what it should be doing. So based on that, I will provide the user query in it, and it has to generate the Python code. So I have given some examples also. So this is the template which I have defined, that what exactly I want and in what format I want my output to be to handle the CSV dataset. So that prompt I'm importing over here. Next I'm importing OS, operating system, and here I'm importing RE, which is regular expression, to extract the particular information out of the text data. So that's why I'm using a regular expression. Next is the open clip embedding model to handle the embedded image data, and here I'm using the image loader function, which I have already explained you, the Chroma database, Chroma DB also. This one I am using for a text, and this one I am using to load the image dataset. Here I am importing the warnings just to filter out some warnings, future warnings, other kind of warnings I don't want to show to the terminal. So you can just write over there warnings.filter warnings, and in double quoted or single quoted ignore. Here I have initiated the load.env file, which allows us to load the all credential from the .env file. So I am using os.getenv, and this is the key name which I have given in the .env file. So same key name you have to pass, so you can load that API key which is stored in this .env file. And here I have initiated ChatGrok model. So in this one I am passing the model name, which is Llama 3.1 70 billion versatile model, which I have shown you in the Grok, and I am passing the API key also. Here I am loading the CSV file. We store the grocery data information. I have a CSV file, so that one I am loading with the help of pandas.read CSV. I only need those columns, so I'm just filtering out. And here I have initiated the chromadb.persist client function, pass the vector database. Image loader I have initiated over here, and the clip embedding model is also over there. So I'm creating a Chroma client with my existing image vector database. So in that one, you remember that we have given the collection name is equal to image. So same collection name which I am passing over here. And I am giving the embedding model, which is clip, and the image loader, which is over here. Next I am creating a function. This function will going to, based on the user query, if that decision has been made that the user needs image dataset, so it will going to run this function. So this function is a search image database. It will take a query, which is user query, into the string format. Number of output I want, means number of images I wanted to retrieve. So I wanted to 4, so that I have written over here. And the try and accept block. So in the try block, I'm using the response image vdb.query. So this image vdb, if you have watched my other videos, which includes the how to build a fashion AI assistant, so in that one I have told you that we have several kind of ways to retrieve the data. You can retrieve based on the query embedding, query text, query images. That one you need to pass the image, and based on that the similar image it will going to retrieve. You can retrieve with the help of URIs also, means unique resource identifier. So I am just using a query, and in that one I am passing the user query, which is going to be over here, number of result which I wanted to retrieve, and what I wanted to be included in the retrieve. I wanted to include URIs and distance, means during the similarity search what is exactly the distance between the user query and the stored embedded images. Finally we are returning the response. If there will going to be any error, it will going to throw the exception. Next, to check the logic, means whatever the user query is going to be, LLM will decide what to do. Do I need to use the database, or user is just asking a normal question like hi, hello and other stuff. I have utilized this LLM model to do the decision. You can use the function calling also, that one. In future videos I will going to include that also. Or you can use the logical way, means if this word is present, or you can write simple or complex logic based on your need. So I have written the prompt over here. This is the function is check if the data is needed. So in that one I am passing the user query, which is going to be string. The output is also going to be a string format. The prompt I have defined over here. The user has asked, this is the user query, and determine the appropriate response based on the question. If the question is related to cloth, so in that case it will going to respond images. If it is related to grocery store item, then it will going to respond with the groceries. If it is related to fine tuning LLM model, then it will respond with the fine tuning, else it will respond normally. If those are the notes scenarios the user has asked, means just going to be a normal question or other question. So output should be one word. So that's the instruction I have given to the LLM model, like image, grocery, embedding, fine tuning or normal. That output should be. So template I have defined over here. So in the prompt template which I have imported from the over here, so that's the template we are defining to give the instruction to the LLM model. In that one I am passing this prompt. The input variable is user input, because we have given over here in user input. So this prompt is required this user input. So input variable which I have given over here. After that I am creating a chain. You can create chain with simply like this, template and LLM, and after that I will just going to invoke this chain by passing the user input. So the chain dot invoke function, and I have passed the user input because it requires an input variable as equal to user input. So that I'm passing over here, and then dot content. From the content section I'm just taking the output into the lower letter. Over here you have seen that what are the decision it has made. We're going to return the decision. We have seen that to search the image database, this function will going to be called, and get data from a CSV, this function is going to be called. So this is the function get underscore data from CSV. This will take a user query as an input, and output going to be a string format. And here I have given the prompt template, and in this one I have given the prompt template for question which I have shown you over here. So that template which I will going to give in this one, and input variable is going to be a user query, and again I'm creating a chain, then invoking that chain. So this what it will going to do, user query is if it is will be related to the grocery, like this one. If it was related to a grocery, so this function will be called, and then based on that LLM will going to generate the Python code out of it. So output, from that output I will going to extract the Python code, and then how I am doing it with the help of regular expression. So this regular expression will allows us to take out the particular information from that whole text. So that pattern I am matching with the output dot content array dot all. So it will going to extract that Python code, and then I will going to execute. If it will be matched, then in the try block I will going to execute with the help of evaluation. So in that one I am taking the matches first one, which will going to have a code. So that code I will execute. It will automatically going to take that the variable which I have given df. So you just need to give the variable name df anywhere in the script. So it will take that data frame and this code which are passing over here, and it will execute and it will return the result. So that result I am converting into the JSON format, and that result I will going to return. If it is not able to work, then exception handling will going to take care of. Next function I return respond to user. So this function will take the user input into the string format, then it will going to call the decision function, which I have shown you the check if the data is needed. So this function will be called. In that one we will pass the user input, then it will decide that do I need the data set and which data set I need, or it's just a normal, whatever decision it's going to be. Accordingly all the function will be called. If the decision is related to the grocery, then the grocery data function will be called, means which is get data from the CSV. If it is related to image, then image data function will be called, which is over here. So all the function will be called according to the decision. If it is related to the fine tuning, then I have not written the function over there, I just rewrite the code in this one. You can write the separate function and call it over here. So this is the persist direct path I am passing over here. So this is the PDF VectorDB and the embedding model which I am utilizing all many LM6 v2, and the Chroma database I have initiated by passing the persist direct, and embedding model which is over here, so that I'm passed over here. This VectorDB I'm calling over here VectorDB dot as retriever. So in this one, search keyword argument is equal to k equal to 1, means only I wanted to retrieve one relevant data based on the user query. So if you wanted to more 2 or 3 chunks, you can do it accordingly to your needs. This VectorDB as retriever function support different kinds of retriever. In my other videos you can check it out, but let me tell you that the by default it will going to use a similarity, and others are like maximum marginal retriever, which is also known as MMR, or similarity score threshold, means you will going to define the threshold. If the similarity score is more than 70, only then you will going to retrieve. So that threshold you also can define. So there are different ways also, so whatever way you want it. By default I'm using the similarity. So next one is a retrieval QA chain. That chain I am creating, this is the also a way to create a chain, and other way I have already told you. So in this chain I am passing the large language model, which is our Llama 3.1 70 billion versatile model, and the chain type is a stuff, and the retriever which is over here, and the return source document also is equal to, means it will going to return the source document. And here I have passed the question, means this is just a prompt. You are a helpful AI assistant, your job is to generate output based on the query, and then that I am integrating in this query. The whole this will convert it into a prompt, or you can just define the prompt template also over here, and then that query I am passing into the QA chain which I have created over here, and that output LLM response I am taking out the result section, so that will contains the output based on the user query. Else if those are not the 3 scenarios, means grocery, image and fine tuning, so in that case you are just a helpful assistant, and input variable I am giving as a user input. So that chain I have created here, I have invoked that chain, and LLM is going to generate according to the user query. Finally I am creating st.title, which is just for a UI. This is the headline, or the title is going to be front of UI. So here user query text input I have created, which is over here. So that's the enter your query, and this is the text block I have created. Here I have created the st dot button. This is the submit button I have created. If the user has entered any query, then it will going to respond to user function, which is over here. And if there is no user query and still user is clicking on the submit button, then it will ask the please enter a query. That was the way to create this whole project. I hope you learn, and I have explained everything from the scratch how to build such kind of project. For more such video, please like and subscribe. Thank you for watching this video.